I used to think that if I studied well at a top university, I would definitely become a strong engineer. But in reality, what you study at university doesn't necessarily mean you'll use all of it in the industry. Let's look at some possible reasons why even hardworking students can fall behind. This problem is often seen in Ukrainian universities, so let's consider it in that context. First, students are required to study subjects that are not always critical for their field, such as philosophy or history. Second, some areas of mathematics or physics are not always used later in practice. Third, the system of choosing courses is often inflexible, making it hard to adjust your learning path. Skills are not learned effectively when they are simply memorized, as often happens when preparing for exams. And after a few years, most of that knowledge just disappears. Because the curriculum is either too broad, outdated, or poorly delivered, students sometimes underestimate important subjects. For example, graph theory is not only used for finding shortened paths, but also for building compilers and many other systems. But if it's taught in a boring way or without real-world context, students may not understand its importance and lose valuable knowledge. Without practical context, it's easy to miss how important something really is. I studied computer engineering at the bachelor's level at Kyiv Politechnic Institute and also participated in a 2-year mobility program at Kyoto University. I thought that after graduating I would be able to immediately build complex embedded systems. In my final years, I started to feel that while my university education gave me a deep understanding of how computer systems work internally, it didn't really teach me how to actually build them or how to choose effective tools. After noticing these gaps, I decided to work on several practical projects. For example, when I started working on my bachelor's project, an industrial equipment monitoring system, I realized I needed additional skills. First, I didn't understand what real-world problems engineers face or how to apply my knowledge to solve them. Second, during studies, microcontrollers like Arduino are widely used. They are great for beginners, but in real systems they are rarely used due to limitation in flexibility, performance, and cost. Third, although I had heard about existence of real-time operating system, I didn't actually understand how they work or how to use them. But in real embedded system where you have sensor, data processing, networking, and storage happening at the same time, it's very difficult to maintain stability without such kind of operation systems. The real challenges started when theory met reality. While working with analog current sensor, the data turned out to be noisy and unstable. It wasn't enough to just read the signal. The system had to work reliably, and the problem wasn't just filtering or power stability. It depended on many factors. For example, even sensors from the same manufacturer could give different readings, so calibration was required. At that point, it became clear that writing code and running simulation is not enough. You need to understand how the system behaves over time, how its parts interact, and how it reacts to the real world. In the end, I realized something important. The problem wasn't the tools of the university, it was that I didn't yet know how to solve real engineering problems. First, Understand problems, not just tools. Engineering is not about how to write code, but about what problems needs to be solved. You can learn popular tools, but if you don't understand how they help solve real problems and don't apply them in practice, their value drops significantly. Second, the best solution is not always the most complex one. Sometimes you can spend a lot of time building something complex only to realize that the ready-made solution already exists. So the best engineer is not the one who builds everything from scratch, but the one who can find and effectively use existing solutions. Without practice, everything may seem clear until you try to build something and suddenly nothing works. I'm not saying theory is useless. On the contrary, it's critically important. But it must be reinforced with real projects. For engineering growth, it's useful to use roadmaps. They help you understand which technology are the most important. By mastering these technologies and applying them in practical projects, you can make much faster progress. Don't try to learn everything or chase every new technology. The number of tools you know does not make you a good engineer. Also, don't focus only on grades in university. A practical project often gives you far more than extra effort for a higher exam score. Instead, it's better to choose a direction, identify which problem you want to solve and what kind of engineer you want to become. I enjoy building real embedded systems, not just writing code, but creating solutions that can be used in the real world, especially in industry. I'm interested in implementation details, how systems work at low level, how they behave under constraints, how to make them reliable and efficient. I build systems, improve them, and share what I learn. Over time, I realized you don't become an engineer by the amount of knowledge you have, but your ability to solve real problems. So don't wait for perfect preparation. Start building now. Because what matters is not what you learned, but what you can create.